So in this unit, we've learned a lot of different ideas about quadratics. So at the very least, we've learned that when we have a quadratic equation or a quadratic function, we can graph it and it looks like some sort of U shape, either opening upward or downward. We've spent a lot of time thinking about what these particular points are. So if we can find the roots of the quadratic, so these are roots, then we're getting in much better shape. And we've also learned that we can do that a number of ways. So we can use the quadratic formula. We can find those roots by saying x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. We've also learned that we can convert something using completing the square into the vertex form. So we can do a times x minus h squared plus k, and we can find the vertex from that. We've also learned the general idea of factoring using the box method. So we have this nice visual where we're able to just use that and on relatively simple equations see if we can go ahead and factor those. We've also paid a fair amount of attention to some special cases. For example, we learned that if we have a parabola that opens above the x-axis, or maybe we have another parabola that opens below the x-axis, we know that when we're looking at that we're not going to have real roots, but now we have something called complex numbers that's going to help us write those roots in terms of complex numbers. So we've also learned that additional special case where we have exactly one root. So maybe we have a graph and we have a parabola that touches the x-axis at exactly one point. And we've also learned that that can happen sometimes. So we want to put all of this together and solve some pretty interesting problems with these ideas that we formed. We're being asked to consider the function f of x equals 2x squared plus 2x minus 4. And they want us to find a domain that would keep the range under 20. Now, when we look at that, they're talking about domain and range. I have to remind myself of what those things are. So first of all, domain is dealing with all our possible values of x. Range is dealing with all our possible values of y. So I know that I want my y to be under 20. So to do that, I'm going to try and solve this equation. I'm going to set my y equal to 20, and I'm going to write out the equation. 2x squared plus 2x minus 4. And my hope is that by setting this y equal to 20, I'll find values of x that will keep my range under 20. In other words, I will find items in the domain, my values of x, that would keep my range under 20. So let's see if this process works. So first of all, I recognize that 20 is divisible by 2, so is 2, so is 2, and negative 4 is also divisible by 2. So I can multiply everything by 1/2, and that'll make my numbers a lot more simple. Okay, so now I'm going to have 10 equal to x squared plus x minus 2. Now I remember that I need to get 0 over on this side, so I'm going to subtract 10 from both sides. I'm subtracting 10 because this 10 is positive, and so I need to subtract 10. I need to do that opposite operation. So now I have 0 equal to x squared plus x minus 12. So I recognize that we have gone through a video already on how to use the box method to factor. So I'm not going to go through that process here. I'm just going to go ahead and factor it myself. So I'm looking at x plus 4 times x minus 3. If you wanted to verify that this and this are the same, I could go out and FOIL it myself. So in other words, I could take these, I could multiply them together to get this value, and just verify that I've done the math appropriately. So we know that x is equal to negative 3. Excuse me, said that incorrectly. X is equal to negative 4 and positive 3. So to confirm that I have a domain of between negative 4, so anything greater than negative 4 and anything less than 3, I'm going to confirm that that domain keeps me in the appropriate range. In other words, if my x is from negative 4 to 3, then my range should be under 20. So to do that, I used a computer algebra system to make sure that I had done everything appropriately. I don't expect you to have to verify that yourself on your own paper, and I especially don't expect you to need to go to a computer algebra system. I just wanted to show you the result that I got to verify to you that this was actually done correctly. So I'm going to construct a table that I formed based upon that computer algebra system. So I'm entering values of x, and I'm getting out values of f of x. So I went ahead and wrote in the values that I obtained in that table, and I see that my solution worked. So when my x was between -4 and 3, so it was when it was within this area, or when my x is within that area, my f of x, my output, my range, stayed under 20. So when I put in -4, anything between -4 and 3, and for x, I stayed under 20 in my range. Anything here, stayed under 20 there. So clearly this method worked. This question isn't incredibly difficult. The main challenge of it is recognizing that what domain is, what range is, and how we can use that to actually construct the problem. Once you realize what they're asking, it's not too bad. So this question is asking me to consider the function f of x equals x squared minus 4x plus 5. And they're telling me to translate the function 3 units right and 4 units up. So to do that, I need to know where my function is on the graph. In other words, I can't move the thing before I know where it's located. So to find where that vertex is, where that bottom part of the parabola is, I'm going to need to go ahead and use completing the square to get this thing into vertex form. But I know that I can't just add something in without taking it away. So I also have to come right back and take away the very thing that I just added. Then I'm going to do a plus 5. So I recognize that this side of the equation and this side of the equation, that this side and this side are ultimately the same thing. The only difference is we've added in this plus -2 squared and this minus -2 squared. Okay, so we know that we can take these terms and break them apart into a single nice binomial raised to the second power. So that becomes x minus 2 squared. The -4x can go away. And then we're left with minus 4 plus 5. That minus 4 came from the fact that we have -2 raised to the second power. That's positive 4, then we put the minus, so we get a -4. -4 plus 5 becomes positive 1. So I'm going to put in x minus 2 squared plus 1. That tells me that my vertex is going to be 2, 1. Okay, so let's take all of this and set it to the side for a second and imagine what they're asking us to do on our graph. So I'm going to come up here, I'm going to sketch a graph to the best of my ability at least. So there's my y-axis, here's my x-axis. I know that this parabola is located, let's say, right here, and it has this vertex of 1, 2. 2, 1. So we want to transfer that thing 3 places to the right. So it needs to go 1, 2, 3 places to the right. And then it needs to go 4 places up. It needs to go 1, 2, 3, 4 places up. And we'll get a new parabola, which I guess I'll go ahead and indicate maybe in purple. So that new parabola is going to be somewhere up here. So what's the vertex of that new parabola going to be? Well, I'm going to take 2 as my x-coordinate. So I'm going to take this 2 and add 3 to it since I'm going 3 places to the right. So I'm going to write that in as 5. And then this 1 I'm going to increase by 4 because I'm going 1, 2, 3, 4 spaces up. So I need a new parabola at 5, 4. I know how to write, once I'm given the vertex, I know how to write a parabola with a given vertex in vertex form. All I have to do is come in, and I'm going to write out my final answer. It's going to be y equal to x minus 5 raised to the second power plus 4. So I was able to take, so this is my final answer. This is my original parabola, only it's been translated 3 places to the right and 4 places up. Okay, so the question again wasn't too bad. It's just knowing that it's asking you to work with completing the square and with vertex form. Okay, this is going to be my final question of the video. They're asking me to find a parabola with a vertex whose x-coordinate is 1 and with a root located at -4, 0. So there's actually not too much algebra that we have to do here. They're giving us one root and the x-coordinate of the vertex. So let's just see what they're giving us on a picture. So I'm going to go ahead and draw my tick marks. So I have one root located here at -4. Let me draw in my tick marks over on this side. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And it has an x-coordinate at 1. So I don't know where the y-coordinate of the vertex is located, but I know the x-coordinate is at 1. So maybe the vertex is here, or maybe it's up here, maybe it's up here. It doesn't matter. So all it tells me, the only requirement I have is that the x-coordinate of the vertex has to be at 1. So I'm just going to come down here and put that my vertex is 1, comma, and then something. I don't really know where it's located on the y, and I don't need to. This is my other root located at -4, comma 0. I'm going to go ahead and sketch in what this parabola might look like. Okay, so I've done that, and maybe it just comes somewhere up here. The idea is that a parabola is symmetrical. If I'm looking along this side, I should be able to flip it over this line of symmetry and get a similar side, a similar arc on the other side of that line of symmetry. So that tells me that if the distance from one root to this line where the x-coordinate of the vertex is represented is 5, and it is, I go from -4 to 1, 1, 2, 3, 4, 5, then my distance to the next root must also be 5. So let's see, let's do that. So I'm here at 1, and I need to go 5 places up. So 1, 2, 3, 4, 5. So in reality, my parabola comes right up here. Let me go ahead and erase these. Okay, so now I have that new parabola. Distance from this line of symmetry to the root is 5. Distance from this line of symmetry to the root is 5. I know that if x is 1 here, if I add 5 to that, this point must be 6. So I'm going to come in here and write 6, comma 0. And now I can reverse engineer a quadratic equation that would work. So I can write out y equals x plus 4 times x minus 6. And if I wanted to, I could go ahead and FOIL that out. I certainly don't have to. And so I have found a parabola whose root is at -4, comma 0, and the equation that represents a parabola with a vertex whose x-coordinate is 1. So we didn't really have to do that much algebra. We just had to use the fact that the parabolas are symmetrical. So with this problem, we will conclude this video.